Okay, so going back to inverse functions, we talked about a couple things with this. How to find an inverse function, right? Switch the x's into y, solve for y. That's not always going to work. We talked about the fact that a function and its inverse are reflections of each other over the line y equals x. That's important. And then we're going to start finding the derivative of an inverse function. So I'll show you two main methods to do this. I like the graphical approach better. So here's the other approach. This is the formula method. So you want to write this down. The bottom makes a little bit more sense than using the f prime and the g. So we have two functions. We have f and the inverse f of x. If I want to know what f inverse of x prime is, I think that's the order you'd go in, I would use this formula. The problem is, and you might run into this problem also, I never remember that formula. I can't remember if it's the inverse of the derivative or the derivative of the inverse and the reciprocal and all this other garbage. So I use a different technique. But if you want to use that, it's okay. So in other words, if I have a function f of x and I want to know what is f inverse prime of, let's say, 2, then I can go ahead and use this formula. I have to find f inverse of 2, take that answer, plug it into the derivative, and then take the reciprocal. Okay, and I'll show you an example of what that looks like when you're solving the problem, and then I'll show you the other technique that I like better, but again, you can use whichever one you want. Both of these techniques are based on a simple idea. If the point 3, 2 is on the function, what's the corresponding point on the inverse? 2, 3. So the x and the y coordinates reverse. Okay, so here's a function. 1/4 x cubed plus x minus 1. What is the value of f inverse of x when x equals 3? In other words, what is f inverse of 3? There's a couple ways we can do that. We could go and figure out what the inverse function is, but you can see that that's either a big pain in the butt or it's impossible. We have a function that would be x equals 1/4 y cubed plus y minus 1, and you have to solve that for y. Too much work. So we're going to use a different technique. We're looking for this value here when f inverse is equal to 3. So instead of doing that, I'm going to do this and figure out what x is. Because those are the same thing. If you know the value of the function, then the value of the inverse switches the x and the y's. You can do this, right? How? No. Set it equal to 3. Right, so we would do 1/4 x cubed
This is for A.
plus x, yeah, minus 1 equals 3. And solve that. That's not an easy thing to do, by the way, in this particular function. I probably should have chosen an easier function. So I'll save you the hassles. When you do this, x turns out to be 2. Which means that the point 2 comma 3 is on the function. Therefore, its corresponding point on the inverse would be 3 comma 2. So therefore, this is equal to 2. Okay, that's the first thing you need to get out of this, is that when you look at a point on the function and a point on the inverse, the x's and the y's flip-flop. You with me so far? Yeah. Good. We did that already. Good. Now we took a look at this, and then we just plug and chug. Okay. So I want to know what is f inverse of 3 prime, or f inverse prime of 3, whatever you want, however you want to phrase that. This we just calculated. F inverse of 3 we did in part A, which is 2, and then the function is easy enough that you could find f prime of 2. Take the derivative of the original function, plug in 2, and get your value. So that reduces to that guy. So there's f prime down on the bottom there, plug in 2, and go from there. The trick is in the first part, we have to figure out what that x value is for the inverse. to plug into the derivative. Right, you're plugging 3 into the original formula, but you got to figure out what f inverse of 3 is by switching around. Does that seem like an easy process? No. I agree. I don't think that's the most logical way to do it. So I'm going to show you a different technique using a graphical approach, and the idea that a function and its inverse are reciprocals, or sorry, not reciprocals, are come on, Reedy, what's the word? Reflections over the line y equals x. Okay, so this is an important point that you need to remember in order to use this other technique.
Could you go back 1 second?
Sure. Yeah.
Wait, so how did you make the jump from like the second to the third?
This?
Yes.
We did that in part A. We figured out what f inverse of 3 was by figuring
Set
out where the function is equal to 3.
to 3.
So we found out that 2 comma 3 is on the function, so therefore 3 comma 2 would be on the inverse.
But why would you plug in the derivative of 2 then? That's what I'm a little confused with.
You don't. You plug 2 into the derivative.
Oh, okay.
Good? Okay. So this is a lot of gobbledygook, but let's draw a picture here to show you what I'm talking about. If I have a function, okay, so we got our axes, and I've got a function f of x, something like that, then I know that if I want to see what the inverse looks like, the inverse would be the reflection over the line y equals x. So here's y equals x, and therefore the inverse would look something like that. Okay, you with me? That's nothing new. We talked about that before. What this new tidbit of information is saying is if I take a tangent line on this function, let's take this point here, and that points at a comma b, well, that was weird. How do I find the slope of that tangent line? Derivative. Derivative. Good. So we'll call that slope m sub 1. Now I want to find the corresponding slope on the inverse. So if I went with the point AB on the function, where's the point on the inverse? BA. Good. And that last little tidbit I had, which I'll go back to that slide in a second, to find the slope of this line, we'll call it M2. M2 is equal to the reciprocal of M1. Not opposite reciprocal. What's an opposite reciprocal do? Perpendicular. This isn't a perpendicular, it's a reciprocal. Flip it over. So looking at that picture, in the original problem when I asked you for f inverse prime of 3, I was wondering what is the slope of the tangent line to the inverse at the point 3. So my suggestion to do the problem is not to do this, but to find this. So if I know that I want to find the original problem was what's the, so in this particular example I would be looking for this. Instead of finding this, I'm going to go and find this and then flip it over. Okay, so let's say that turns out to be smiley face. Then my final answer up here is just going to be 1 over the smiley face.
Do frowny face?
It might be frowny face depending on how difficult the function is.
Well, smiley face upside down. Would be,
Or it could be that neutral, you know, that just,
yeah.
you know.
So,
No, smiley face upside down would not be frowny face. Smiley face upside down would be like mega unibrow with no mouth. That's ridiculous, Luke. Get your act together, will you? Okay. Does that make sense? So the way we did the last problem then, if we go back to that, and I think I have another example here. I don't need to go through all this rigmarole. All I need to do is figure out, go back one more, bing. I needed this information. If I'm looking for 3, and if 3, 2 is on the inverse, then I know that if 3, 2 is on the inverse, then 2, 3 is on the function. I'm just going to find the derivative of the original function, plug in 2, take my answer, flip it over, which really is all this formula does, but it takes a little bit easier way. It's a more logical way to approach the problem.
Could we do an example?
Yeah, I think I have one in here. If not, I'll make one up. Click, 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 click. Okay, so here we go. We'll start with something simple like x squared. So the 0.24 is on x squared, therefore the 0.42 would be on the inverse. I keep belaboring this point. Are you with me on the whole switching locations or coordinates thing? So I don't need to keep beating a dead horse. Okay, good. All right?
I'm dying.
Well, everybody's dying technically.
It's so depressing.
Just dying
It's so
that's right.
look at it.
I think living forever would be more depressing.
Yeah.
Watching all your friends die, your family die.
Over and over again.
Yeah.
Unless you were like the Highlander where you got to carry a sword around all the time.
Well, you probably could still do that.
That was
Yeah.
Bicentennial Man,
Is it?
But he was a robot,
Why
wasn't
do
he?
you-
but he became human.
No, imagine if you got.
No, he went the other way though. He didn't. He went from being a robot to being human, right?
Yeah. Okay, so he
Oh, it's
essentially.
the
Right.
inverse.
Yeah, so he didn't.
And then the
he
government.
didn't. Okay. So, anyways, where are we at?
Can I have my
So, in a problem like this, I would ask you something like, what is? And I'm not sure where I'm going with this slide, so I'm just going to give you this. I would ask you something like this: prime of 4. So that would be the problem.
So we don't even know that?
Well, we'll get to that in a second.
Okay.
Are we using the?
Which means that I need to know what the other point is. Well, I chose an easy function so we can see that. If x is 4, then y is 2, which is what I have here, which means then that 2, 4 is the point we're going to work with in the original function. Okay, and again, for those of you that are visual learners, we've got this. We've got the square root of x, and we've got x squared, or part of x squared, because we're doing only greater than 0. So at 4, 2, 1, 2, 3, 4, 2, I'm at that point. I don't want that 4, 2 point. I want the point 2, 4. Okay, so this is f. Whoops, no, that's f, not f prime. This is f inverse. I'm going to find the slope of this tangent line from the original function, and then take the reciprocal, and I get the slope of the tangent line to the inverse. So I'm going to need to use 2 in this. So I'm going to find f prime of 2, which is easy. Take the derivative of f, you get 2x, put in 2, you get 4. Take the reciprocal, 1/4. So the answer to this problem over here will be 1/4. Does that make sense?
Can you do that again? Yeah.
What's that?
Can you break it down?
Sure. I know that 4, 2 is on the inverse, so that 2, 4 is on the function. So 2, 4 is on f of x. So instead of finding this, I'm going to find f prime of 2. I'm going to use the y value from the inverse as the x value in the function. That turns out to be 4. So in other words, the slope of,
Can you do that? Like, how'd you get that parameter?
took the derivative of that
Okay.
and plugged in 2. So that means that the slope of this line, that tangent line, is 4. To get the slope of the tangent line that I'm looking for over here, which is a derivative, I just have to take the reciprocal. So then f inverse prime of 4 would be 1/4. Okay. Find the corresponding point on the function, take the derivative, plug that corresponding point in. Last thing is to take the reciprocal. This isn't a huge point. This isn't a deal breaker. It's not as important as taking a derivative or any of that other stuff. It is something that pops up occasionally. Now you have two different techniques to use it. Some of you are just going to memorize the formula. That's okay. There's nothing wrong with that. But again, if you want to use a graphical approach, here's a different way to solve the problem. Okay?
That circle on the x squared is pretty impressive itself. It's not perfectly circular, but it's completely closed.
You know, I found I can't do perfect circles on the smart board because it doesn't keep up fast enough.
Oh, really?
So, you know, when I draw a circle, I do it pretty quick.
Well, can you do a perfect one on the whiteboard?
No, I can't do it on the
No,
white.
no.
Oh, over there? Pretty close, yeah. I'm out of practice.
I think
but-
we've seen this.
Yeah, in geometry.
Yeah.
Can't
Yes,
you
sir.
just put a big dot and then make the eraser slightly smaller and then hit the center of that and it will take out the center part?
Well, that's called cheating.
No.
What we were talking about is doing,
I know which way you were talking about, but you could do it that way too.
okay, so now it is working. It can't.
There is,
You
like,
sure
there are
it's
people that do
like-
professional, there are
Oh
people
my
that
God,
do,
love it.
like professional circle drawers.
That's
pretty
pretty
good.
good.
That's pretty good.
It's not my first time at the rodeo, kids, you know what I'm saying?
Want to say that louder, Ashley?
No, I'm good.
And I'm recording.
What?
I just said like it's not fully closed.
You're right. You're right. I noticed it too.
Okay.
Yeah. I'm already beating myself up for it. I don't need your help.
That's why I whispered it. I didn't want you to make me feel bad.
It was kind of Ryan to butt his nose in. Butt his nose in? Stick his nose. I don't know, those probably aren't two words that should go together. Okay, so there's our final product there. And again, whichever one you want to use, I don't care. I like the graphical approach because that's how my brain works. If you're a memorizer and you just want to plug and chug, regardless of what technique you use, you got to have that switching point thing under control.
Wait.
What is it?
2 seconds.
Today's lesson, by the way, is much easier. Much easier. Like ridiculously easier.
Wait, so I'm assuming to summarize this, find the point, take the derivative of that point on f of x, and then split it,
I love John Stewart.
and that's it.
That's it?
Just add the two numbers. I don't know, not posted on
That's not our-
place.
what were you gonna say?
Yep. Okay, so stop this.